Assalamualaikum and good day class. So, hari ni kita akan masuk chapter 3, okay, iaitu electrochemistry. Okay, before we start, Madam nak, okay, semua bersedia duduk tegak dan baca doa sebelum belajar, alright? So, kita tengok apa yang kita akan belajar hari ni, alright? So, electrochemistry, what is electrochemistry? It is the study of the relationships between electricity and chemical reactions. So, for this chapter, we have 3 subtopics: galvanic cell, 3.2 Nernst equation, 3.3 electrolytic cell. So, today, kita akan tengok galvanic cell, okay, which Madam bahagikan kepada 4 bahagian. Okay, so untuk galvanic cell, dia punya learning outcome dia panjang sikit berbanding dengan lain. Alright. So we look first the learning outcome for this subtopic. Okay, so at the end of this subtopic, you should be able to define electrode potential, draw a voltaic or galvanic cell, describe the operation of voltaic cell, state the function of a salt bridge, express a half cell equations and overall cell reaction equation, illustrate a galvanic cell using a cell notation, define standard reduction or electrode potential E0, standard cell potential E0 cell, draw and explain the operation of the standard hydrogen electrode She, construct standard reduction or electrode potential series by using She, use the standard reduction potential values to compare the relative strength of oxidizing and reducing agents, calculate the standard cell potential using E0, and predict the spontaneity of a redox reaction. So, let us start. So, electrochemistry involves redox reaction. What is redox reactions? Redox reaction is the reactions involving oxidation and reduction. So, we look first reduction process. Reduction involves loss of oxygen and addition of hydrogen. It gains electron and oxidation number increase. Oxidation number decrease. For reduction, oxidation number decrease. So, reduction process takes place at cathode. Alright, so cathode ni adalah sejenis electrode. So, kita ada 2 jenis electrode, which is cathode and anode. Alright, so for example, we have this half equation. Okay, look for the equation Cu2 plus, okay, it gains 2 electron, okay, so reduction process, it gains electron, okay, produce Cu solid. So, the oxidation number here, the oxidation number for Cu2 plus is plus 2, Cu is 0. So, oxidation number decrease from plus 2 to 0. So, it is reduction process. And then, what about oxidation? Oxidation is addition of oxygen and loss of hydrogen. It release of electron or loss electron. Okay, the oxidation number increase. Okay, oxidation, that means oxidation number increase. It takes place at anode. Alright. So, for example, we have this half cell equation. Zinc solid produce zinc 2 plus aqueous plus 2 electron. That means zinc lost 2 electron to produce zinc 2 plus. So, the oxidation number for zinc is 0 and oxidation number for zinc 2 plus is plus 2. So, oxidation number increase from 0 to plus 2. So, it is oxidation reaction. So, what is important here, okay, kamu kena tahu nak buat dia punya half equation. Kena mahir buat half equation. Nanti kita ada exercise. Alright. So, macam mana nak senang ingat? Reduction, okay, pada cathode dan oxidation pada anode. So, kita tengok analogi ni. Reduction, kita ingat red cat. That means reduction at cathode. red, cat, reduction at cathode, and for oxidation, anox, okay, iaitu anode akan berlakunya proses oxidation. So we have two types of cell, which is electrochemical cell is divided by two, galvanic cell and electrolytic cell. Galvanic cell yang kita akan tengok pada subtopic 3.1, and for electrolytic cell kita akan tengok pada the last subtopic 3.3. So what is galvanic or voltaic cell? Okay, dia adalah benda yang sama, galvanic or voltaic. Okay, it convert chemical energy to electrical energy. That means this cell generates electricity. But then for electrolytic cell, okay, it converts from electrical energy to chemical energy. So this cell uses electricity. So another difference between the galvanic and electrolytic, for galvanic it is spontaneous redox reaction, it releases energy, and then for electrolytic cell non-spontaneous redox reaction. Alright, so for galvanic, cathode is positive terminal and anode is negative terminal. But for electrolytic cell, cathode is negative terminal, anode is positive terminal. But then, okay, what is the similarities between these two cells? Oxidation occurs at anode and reduction occurs at cathode. Is still the same, okay? That means for oxidation still at anode walaupun dia punya terminal berbeza. Reduction still at cathode, alright? And then anion will move to anode and cation will move to cathode. And then what about electron flows? Okay, electrons flow from anode to cathode in the external circuit. Okay, so the diagram for galvanic is like that. For galvanic cell, okay, we have two solution, okay, and electrode here immersed in the in each solution. So we have salt bridge here, and then this is the external wire. Okay, and then for electrolytic cell, we have just only one solution, and then both of the electrode immersed in that solution. Alright, so kita akan lebih pergi terperinci selepas ini. Okay, so what is the basic features of electrochemical cell? Okay, so this is a diagram for galvanic and electrolytic cell. So we have electrode yang dalam keadaan solid ni. Okay, dia akan immerse dalam solution. Kita panggil dia electrode. Object that conduct electricity between cell and surrounding. So, electrode is divided by two, anode. Okay, anode adalah oxidation, berlakunya proses oxidation, and cathode reduction occur. Alright, so we have two type of electrode, anode and cathode. Alright, and then the solution here we call it as electrolyte. So electrolyte is a mixture of ions, usually in aqueous solution, that are involved in reaction or that carry charge. Alright, so itu adalah terms yang perlu kena ingat dan faham. Alright, so now kita masuk 3.1 galvanic cell. So galvanic cell, also known as the voltaic cell, it consists of two different metals immersed in an electrolyte. Okay, masing-masing ada dia punya electrolyte masing-masing. The more electropositive metal, okay, adalah pada anode. Anode pada galvanic cell adalah negative electrode. The less electropositive metal is cathode. Okay, so cathode is positive electrode or positive terminal. For example, for galvanic cell is Daniell cell. So what is Daniell cell? Okay, Daniell cells is more specific to solution, which is zinc sulfate and copper sulfate. Okay, dia spesifik untuk zinc sulfate and copper sulfate sahaja. Okay, selain daripada itu bukan namanya Daniell cell. It is general, iaitu galvanic cell sahaja. Alright, so we have two electrode, okay, zinc electrode and copper electrode, and then wire, and we have voltmeter. And after that we have salt bridge. Okay, salt bridge ni ada solution juga di dalam ni. And the electron flow from anode to cathode. Okay, electron flow from anode to cathode. And then what about the ions in the salt bridge? The negative ion or anion from the salt bridge, okay, akan pergi ke anode. And then the cation from the salt bridge will go to the cathode. Okay, so cathode, again, cathode is positive terminal, anode is negative terminal. Okay, the negative or an anion from the salt bridge, let's say we have salt bridge, we use here KCl, KCl salt bridge, ada solution KCl dalam ni. Okay, so that's mean the Cl minus, okay, dia akan pergi ke solution, iaitu pada solution yang anode, okay, half cell yang sini, and then another one K plus, which is the cation, dia akan pergi ke sini. Alright, so bila kita nak lukis, mesti kena label all these things. Alright, so the salt bridge. What is the salt bridge? It made of a filter paper soaked in an inert electrolyte such as saturated KNO3 or KCl. Okay, ataupun kita boleh menggunakan inverted U tube containing a gel permeated with the solution of an inert electrolyte such as KCl, Na2SO4 or NH4NO3. Alright, so ada dua pilihan. Biasanya kita akan guna di college kita menggunakan filter paper sahaja. Kita rendam dalam KCl ataupun KNO3 solution, and then kita akan immerse dalam kedua-dua solution di sini. Okay, like that. Okay, kita just letak sahaja between the two electrolyte. Alright. So, what is the function of salt bridge? The function of salt bridge is to separate the two electrolytes, to maintain the electrical neutrality, and to complete the circuit by allowing the ions to move between the two electrolytes. So now kita tengok the operation of voltaic cell. Zinc is more electropositive than copper, so that the zinc is at anode side. Okay, zinc atom release electron to form zinc 2+. Okay, kalau kamu tak pasti macam mana, kamu tengok, kamu just buat dulu dia punya equation. Okay, we know that at anode, okay, the process occur here, oxidation process. So oxidation, dia punya oxidation number will increase. So we must start from the low oxidation number, which is zinc. Zinc dia punya oxidation number is 0. Okay, so dia akan release 2 electron to become zinc 2+. So zinc 2+ oxidation number is +2. So from 0 to +2 oxidation number increase. So that means it is oxidation. Okay. So zinc electrode adalah anode. Okay, which is dia berlakunya proses oxidation. Alright. So, zinc electrode release electron. Therefore, it is the negative terminal. Okay, and then zinc atom produce zinc 2+, so zinc dissolve. So, that's mean lama-lama zinc dekat sini dia akan become thinner. Okay, dia akan jadi kurus macam tu, terhakis. Alright. So, electron, okay, electron move through the wire to the copper electron. So tadi kita nampak zinc tadi dia dah release electron. Dia pergi mana electron? Pergi melalui apa? So dia pergi melalui wire ni. Okay, dia pergi ke copper electron. Okay, copper pula, okay, dia akan terima electron. So Cu2 plus ion in CuSO4 solution accept the electrons to form copper atom. So the equation will be like this. Cu2 plus 2 electron produce Cu solid. So let's check the oxidation number here. Cu2 plus, okay, the oxidation number is +2, and then the Cu is 0. So oxidation number from +2 to 0. So the oxidation number decrease. So that means it is what? It is a reduction process. Okay, so reduction process, that means copper is cathode. Alright. So copper electrode receives electron, therefore it is positive terminal. Okay, yang dibuang elektron tadi adalah negative terminal, which is anode, and then for here cathode is positive terminal, it receive electrons. Okay, so Cu2 plus reduced to copper. Okay, macam kita tengok equation tadi from Cu2 plus. Okay, dia receive 2 electron, it becomes Cu solid. Kita tengok pada produk dia adalah menghasilkan solid. That mean pada copper electron lama-lama akan ada reddish brown solid deposited. Okay, sebab produk dia adalah copper solid. Okay, so kita tengok sekarang, what if there is no salt bridge? Okay, let me see. So this is the diagram without the salt bridge. So the electron from the anode to cathode, okay, dia tak boleh continue, okay? Sebab apa? Okay, as the zinc rod dissolve, okay, the concentration of zinc 2 plus in the left beaker increase. Okay, because the equation here, okay, let's say kita tengok balik dia punya equation, okay, zinc, it becomes zinc 2 plus, dia release 2 electron, okay. So lama kelamaan, okay, dia punya positive charge pada this electrolyte become increase. Okay, that means the concentration of zinc 2 plus increase. Okay, tengok produk kita adalah zinc 2 plus. So the reaction will stop because the net increase in positive charge is not neutralized. Okay, so dah terlalu banyak dekat sini yang bercharge positif. Okay, so dia reaction akan stop. So this excess charge build up can be reduced by using a salt bridge. Okay, macam mana kita nak neutralize balik yang terlalu banyak yang bercharge positif tadi pada zinc electrolyte. Okay, so kita akan menggunakan salt bridge. For example, KCl salt bridge. Okay, so let's see what happened to anode. Okay, the half equation is like this. Zinc becomes zinc 2 plus, and then at cathode, okay, dia akan become Cu2 plus, receive 2 electron, become copper solid. Okay, so bermakna dekat sini dah terlalu banyak apa? Dah terlalu banyak bercharge negatif. Okay, sebab apa? Dia terima elektron. Okay, di sini pula dah terlalu banyak bercharge positif sebab dia menghasilkan zinc 2 plus. Okay, so itulah kegunaan salt bridge, okay, iaitu dia ada solution yang ada ions, okay. So the negative charge iaitu Cl minus, okay, and then positive charge from the salt bridge iaitu K plus, dia akan pergi ke tempat masing-masing, iaitu pada Cl minus dia akan neutralizekan yang banyak positive charge di sini iaitu zinc 2 plus. Okay, so yang K plus akan pergi ke tempat yang banyak negative charge iaitu elektron, terima elektron di sini. Pak, elektron dah banyak dekat sini terima, so dia kena pergi yang cation from the salt bridge, dia akan pergi ke electrolyte yang mengandungi terlalu banyak elektron. Alright. So the negative charge pergi pada yang banyak positif, higher positive charge di sini. Okay, and then the positive from the salt bridge akan pergi ke electrolyte yang penuh dengan elektron di sini. Okay. Okay, so the reaction akan sentiasa berlaku. Okay, sebab electrolyte kat sini dia akan maintain dia punya neutrality. Alright, so this is what happened at anode and cathode, and then okay, ini Medan dah terangkan tadi. Okay, the zinc 2 plus enter the solution, causing the overall excess of positive charge, and the Cu2 plus ion leave the solution, causing an overall excess of negative charge. Okay, so banyak negatif kat sini, dah banyak positif kat sini. So Cl minus ion from the salt bridge, okay, move into zinc half cell. Okay, sebab negatif dengan positif dia akan neutralize balik, and then K plus ion from the salt bridge akan enter the move to copper half cell. So the positive charge here and the negative charge daripada electrolyte dia akan neutralize balik. So the electrical neutrality is maintained. Alright. So dah faham pasal salt bridge, dah faham function ataupun operation of the galvanic cell. Okay, madam nak buat homework, page 8. Okay, so complete the equation here, ada anode and cathode, and also the overall equation here. Alright, so kita akan sambung pada video seterusnya. Thank you.